Function binding in Python agents explained. Dive into the world of dynamic programming with function binding in Python agents. Learn how to create flexible, responsive code structures and enhance your programming projects.
Welcome to our exploration of function binding in Python agents. Function binding is a core concept that allows a function to be associated with an object, providing a powerful way to create dynamic and flexible code structures. Imagine you have a toolbox, and each tool inside is a function. Function binding is like attaching a specific tool to a task, enabling you to switch out tools as needed without altering the entire toolbox. This is especially significant in dynamic programming where adaptability is key. By the end of this video, you'll grasp how to implement function binding in your projects, making your code more versatile and powerful. Stay tuned as we unravel this exciting concept. Scope and context are pivotal in understanding function binding. In Python, scope refers to the visibility of variables in different parts of your code. When you bind a function, you're often working within a specific scope, whether it be local, global, or non-local. Context, on the other hand, dictates how and where a function can be used. For instance, a function bound at a global scope can be accessed anywhere in the code, while a locally bound function is restricted to the block it resides in. This distinction is critical for code efficiency and avoiding common pitfalls like variable shadowing. As we delve into examples, picture scope as the boundaries of a swimming pool, and context as the rules of the swim meet you're attending. Python offers multiple techniques for function binding, each with unique advantages. Static binding, also known as early binding, occurs at compile time, whereas dynamic binding, or late binding, happens at runtime. This flexibility allows Python to support dynamic programming paradigms effectively. Decorators in Python provide a way to wrap a function, extending its behavior without permanently modifying it. Similarly, Lambda functions offer lightweight, anonymous function binding. Closures are another technique, where a function retains access to its lexical scope even when executing outside that scope. Understanding these techniques empowers you to select the right tool for your programming needs. Transitioning from theory to practice, let's explore function binding through hands-on examples. Imagine you're building a responsive web application. Function binding allows you to dynamically associate event handlers with user interactions, such as clicks or form submissions. In Python, you can achieve this by defining a function and then binding it to an event using techniques like decorators or closures. As you follow along, pay attention to how binding impacts code readability and maintainability. Debugging function bindings can sometimes be tricky, but with practice, you'll learn to identify and resolve common issues efficiently.
Even seasoned programmers can stumble upon pitfalls when working with function binding. A frequent issue is variable shadowing, where a variable in a local scope unintentionally overrides a similarly named variable in a global scope. This can lead to unexpected behavior and difficult-to-trace bugs. Another challenge is managing scope effectively to prevent unintended bindings. For instance, binding a function globally when only a local scope is needed can lead to security vulnerabilities and performance bottlenecks. By adhering to best practices, such as clear naming conventions and thorough testing, you can avoid these pitfalls and ensure robust, reliable code. Function binding unlocks the potential for truly dynamic code. This means your code can adapt and respond to changes in real time, which is crucial for applications like data analysis, machine learning, and web development. With function binding, you can create modular code structures that are easier to maintain and scale. For example, in a dynamic web application, you can use function binding to dynamically update UI components based on user actions without reloading the entire page. This level of flexibility not only enhances user experience but also optimizes resource usage, allowing your applications to handle more complex tasks efficiently.
Many Python libraries support and even enhance function binding, providing built-in functionalities that make binding more efficient and intuitive. Libraries such as Flask and Django for web development, or Pandas and NumPy for data manipulation, often utilize function binding to enable seamless integration and execution of functions. By leveraging these libraries, you can extend the capabilities of your applications without reinventing the wheel. For example, in Flask, function binding is used extensively to route requests to appropriate handler functions. Understanding how to integrate function binding with these libraries can significantly streamline your development workflow and enhance the performance of your applications. For those looking to push the boundaries, advanced function binding techniques offer a wealth of possibilities. Metaprogramming, a method of writing code that interacts with and manipulates itself, can be combined with function binding to create highly dynamic and adaptive systems. Custom bindings and decorators can be crafted to suit specific application needs, providing enhanced functionality and performance optimization. For instance, in a machine learning context, you might use advanced binding to dynamically alter learning algorithms based on real-time data analysis. These techniques require a deep understanding of Python's internals but can yield powerful and efficient results when mastered.
As we conclude our deep dive into function binding in Python agents, I encourage you to experiment with the concepts we've covered today. Function binding is a powerful tool that, when used effectively, can transform your programming projects. Whether you're developing web applications, engaging in data science, or exploring machine learning, understanding and implementing function binding will enhance your code's flexibility and efficiency. Join the conversation by sharing your thoughts and experiences in the comments below. Don't forget to subscribe to our channel for more insightful content, and let us know what topics you'd like us to cover next. Your feedback is invaluable in shaping our future videos.